So in this week, we are going to talk about the experimental design of fMRI. Okay. As you may recall, that in this semester we will go through all different kinds of the fMRI analysis. And for the last week, we have already talked about how can we actually acquire the both signal using MRI, or specifically using the fMRI. And in this week, I'd like to continue how can we design the study, or how can we design the experiment so we can actually manipulate. Manipulate is like a term that we can control, or we can let the participant have some kind of the behavior or functional activity that we can observe using the fMRI. This week, we'd like to go in more details about the experimental design. So as you can see right here, not only would you like to record the both signal right here, we are more intending to have the both signal activated in the way that we anticipated. So I'm going to spend around 2 hours. The first hour I'm going to talk about the general idea that what kind of types that we can use to design the fMRI. And then in the second hour, I'd like to talk about two different kinds of the more like the stimulus timing arrangement that we call the block design and the event-related design. Okay. So let's start from the very first part. Before I introduce anything about the experimental design, you should to keep this in mind. What is the goal? Okay. Here is a sentence for your reference, that the goal of experimental design is to manipulate the participant's experience and behavior in a certain way that is likely to produce a functionally specific neurovascular response. As we said in the last week, now we are not directly investigating the neural activity, but more like the neurovascular response. Okay, so we are actually we can only see the vascular response right here, but of course this is correlated to the neural activity. So the experimental design is so important that if you deliver the design in a wrong way, you definitely have no chance to observe the anticipated vascular response. So in this part, we need to keep in mind that what can we manipulate? Actually, there are three different things that we can do, or we should do. The first part is the stimulus properties. Translated in the plain words, is more like what is presented to your subjects. The visual stimuli or the auditory stimuli. What kind of the visual stimuli you are going to use? A picture, a human face picture, or animal picture, or something else. You need to determine what kind of a stimuli you'd like to deliver. And then what kind of the contrast. When we say contrast, it's kind of the difference. What is your target imaging and what is your control or reference imaging? You need to design this in the right way. And the second part is the stimulus timing. The timing is also a key issue. That what kind of the stimulus you are going to arrange, how tight it will be delivered, or it can be delivered in a very, very loose way, but it may keep your subject in a very boring state. You should understand this point. And the final one is the participant instruction. Before you start the fMRI imaging, you need to remember to train your participant, or to ensure that your participant fully understand what he or she is going to do during the scan. Okay. So the instruction is also very important. What do subjects do with it or during the fMRI imaging? Okay. Regarding the types of experimental design, actually there are four types right here. The first one is the simple subtraction. Okay, this is the very first one that you should definitely try if you are the beginner for the fMRI. And then there are three different design right here. The first one would be the categorical design. Each of them will ask a different question. For the categorical design, you have a very important assumption, that is the pure insertion. Pure insertion means that if you give two different categories of stimuli, each one will only have a specific neural function or brain function. It is a very strong assumption that there is no interaction between two different kinds of stimuli. Okay, but actually this kind of assumption may not always be true, so you need to be very careful when you're using this kind of categorical design. And the second one would be the factorial design. In this one, you are now allowed to consider the interaction between multiple factors. We will give you several examples later, so don't worry about this. And the final one is the parametric design. You can also try to correlate the behavior or the performance of the subjects. For example, the response time. If you ask your subject to do the mental calculation, it may spend some time, but it may depend on the difficulty of the question, or it may depend on the education level of your participant. But anyway, you can try to correlate the response time. It is one kind of the behavior with the brain activity. So this is more like a continuous analysis, not simply the categorical design, but it's more like a continuous measurement. So you can correlate the behavior with the brain activity. Okay. So I'm going to spend several slides to introduce each of them to you, so you may have a general picture about how to use these different kinds of design. So for the very first one, I think this symbol subtraction is the very first step that you should learn. This is exactly the one that I introduced to you in the very first week. That actually you can put a subject into the MRI, and you can just display a video to the subjects. During this video, actually they have two kinds of the conditions. The first one is we called hand relaxing, or just resting state or something. The subject is actually relax his hand, and the only thing that he needs to do is to look at the video or the monitor, okay? And once the video starts to do the hand grasping, the subject is instructed to do the same thing, to grasp his hand in the same frequency, same speed, okay? So you can see, if I put the whole experimental design into a timeline right here, you can see the black line right here is represent the control or rest blocks right here. And these gray blocks right here means that the subject should follow the video to do the hand grasping. And as you can see right here, it's more like the alternative conditions. So resting, hand grasping, and then resting again. It's more like an alternative way. So you can repeat the whole stimuli. I think in this study is repeated for 10 blocks, I think, 10 times. Okay. In this kind of a study, of course, you anticipate that the brain activation should be very significant for two brain regions. The first one, definitely the visual cortex, because the subject is looking at a video. And actually, the stimuli is given by the visual perception. So, of course, the visual cortex will have the so-called the bold pattern that highly correlated to the study design. And the second one is the primary motor cortex. And if the subject is using his right hand, then you will have a significant brain activation for the left brain hemisphere, or for the left primary motor cortex. And again, you can observe the bold patterns is highly correlated to the study design right here. And when we say simple subtraction, that means if I'd really like to see the activation, I will try to investigate the contrast between the hand grasping, or maybe we can say the motion period. That we can use this to subject the control block, that is the resting period right here. Okay. If you do so, if you use the right imaging preprocessing and you use the right statistical approach, then you can observe the brain activation map right here. So again, this one is the visual cortex region right here, primary visual cortex, okay? And this one is the left primary motor cortex right here. So when we say subtraction, that means we try to deliver or try to investigate a contrast. Okay, so this is the most simple way that we can give studies. And for the second one, categorical design is more like a way that we'd like to compare the brain activity between different stimulus types. Okay, so I'd like to give you an example that, for example, we can actually give the stimulus to our subject. In this case, we may give one of the noun. Actually, they have 12 different common nouns right there, but actually these 12 common nouns is actually categorized into two different types. The one type is the animate. That means it is a living animal or something, and another one is inanimate. It's like an just object. So I take these three nouns as the example. For one time, for a specific time, the subject can only see a noun in the screen. So for a particular moment, maybe the subject can see a tiger in the screen. And the subject is instructed to differentiate, to determine whether the noun that is showing on the screen belongs to the animate or inanimate object. He needs to use the button to give the response. If the noun belongs to the animate, then you click the left button. If it belongs to the inanimate object, then the subject needs to press the right button. Okay. So the first one, definitely the animated one. Okay. And the second one, when the subject see the book, of course it is belongs to the inanimate object. So now the subject is instructed to press the right button. Okay. And the third stimulus is again the inanimate one, okay, the bucket. So this is we call it categorical design. In this case, it's two categories. Okay, two categories: the animate or inanimate objects. So now you try to answer a question that when our brain differentiating the animate from the inanimate object, where is the specific location that our brain will activate to do this kind of a differentiation or to do this kind of a classification? Okay, so you can actually compare the subjects when subjects respond to the animated objects. You can actually compare the brain activation to the inanimate objects. Okay, so this is kind of a contrast that you like to observe. However, when you do this kind of contrast, every single time when I say contrast, that means it's more like a subtraction. You try to compare two different stimuli or try to compare two different conditions, and the only thing you can do is the subtraction. You subtract the one condition by another one. Okay. But in this kind of a categorical design, you need to watch out this kind of the procedure. That means cognitive subtraction. If you do the subtraction, you may think it is kind of the mathematical process, but actually in our brain, it's more like the cognitive subtraction. It has a very strong assumption that you need to believe or you need to assume that your brain, every condition in your brain is kind of the pure insertion. That means one condition won't have any interaction with another one. When our brain is doing the differentiation of animate objects, it won't have any overlapping or any interaction region that may correlate it to the inanimate object. It's a very strong assumption that you need to give before you do the contrast or to do the subtraction. However, this is not always true. Let me describe the pure insertion in figures that maybe can help you to understand what does this mean. For example, would you like to probe or to understand the neural structures or brain activation? Okay, underlying a single process, I can put a variable y right here, but you can use an example right here. For example, the face recognition. You'd like to know where is the brain region responsible for the face recognition. Okay, so you'd like to deliver a study that using the categorical design. Actually, there is an condition that you will actually showing a picture that maybe a girl or maybe a boy's face on the screen. And another case we call the control task. Now it's a question that what kind of picture we should display on the screen as the control or as the reference compared to the task. Another human's face or animal's face or something else. If you can really find a perfect control, a perfect reference, actually you can do the subtraction right here. For example, this area is particularly for the face recognition. And if you can really identify a perfect reference right here, you do the contrast or you do the subtraction, you can actually identify the brain region for face recognition. However, how to identify this kind of the control task, what kind of picture you should use is a critical question. If you didn't pick the right control, actually you may not only get the difference right here, for example, you may also get another difference right here, because in the control, you may also lose this part. So by the contraction, you can also see another spots or another regions really activated when you are seeing the face recognition. And then you may give the inference that, oh, actually these two regions are responsible for the face recognition. But actually this is not right, because you didn't give the right control task right here. So if you really want to do the subtraction, you need to really find out that compared to these two different categories or compared these two different conditions, the only pure insertion is specifically located to the region that is responsible for the face recognition. And actually this is pretty hard to reach actually. So I'd like to take the example right here. For example, this is the target face stimulus that we are going to give the subject. Okay, so you can see there is actually the monochromic, it's more like the gray level female face right here. But the question now is, which one is a proper control stimulus? If you have the options right here, which one you'd like to use? For the very first one, it's more like a random picture. It's just like a scrambled one. That there's nonsense, there's no meaning behind the pictures. But if you use this one as the control, actually the component is very different from our human face. There's no specific shape, there's no any concrete shape right there. So actually this reference may, if you use this scrambled picture as the reference, you will identify several different brain areas, because the component is so different between these two. Okay, but if you pick another, for example, you pick the male face right here, it's actually a human face, but in different gender. So it's again, it becomes actually too similar with our target face. So if you do the subtraction between these two conditions, you may get nothing, because it's actually the only difference is the gender. And gender is not the reason or the condition that can evoke the brain region to differentiate these kind of things. So actually in this case, you put things that actually has a concrete or precise shape right there, but this is definitely not the human face. This may be a better choice that actually you have a concrete shape, but not human face. So a bottle, compared to other two, this one is actually the better reference if you want to do the subtraction between your face task and the object task right here. Okay. So think about this when you do the categorical design. If you want to possess the assumption about the pure insertion, pick the right reference or pick the right control stimulus is a very essential issue that you need to keep in mind. And for the second one, we say the factorial design. In this case, actually we combine two or more vectors. In this case, I will pick two vectors right here. Okay, within a task, within an fMRI study, to look at the effect of one vector on the response to other vector. That means we allow the interaction between these two vectors. Okay, so this one is become more complicated compared to the categorical one, but this is more, I would say in a lot of cases, it is a more realistic one, because lots of the interaction may happen between two or multiple factors. Okay, but of course in this kind of factorial design, it makes your inverse model becomes more complex right here. And you always think about, is there any other factors I should also consider? In this case, it's only two factors right here. But if the the problem becomes 3, 4, or 5 factors, the statistical inference may be very, very hard to deliver, actually. Okay, so in this case, I'd like to give you an example about 2 factors right here. The first factor is task. Okay, when a subject seeing a picture on the screen, you may be asked, the subject may be asked to simply seeing or viewing the picture. But another task is not only see the picture, you need to name the picture. You need to say, okay, a sheep. You need to say what you are currently looking at. Okay. So there are 2 different kinds of tasks right here. Simply looking at the pictures or naming. Okay. And another factor is the stimuli itself. For example, you let the subject to see the color picture, or simply just the gray level picture right here. Will the color induce the different brain activation in your brain? If you think this is one of the factors, you should put right here. Okay. So now consider these 2 different factors. You actually have 4 different combinations. For example, display the gray level imaging, and the subject only need to do the viewing task. And another condition, I say A2, is more like the display the gray level pictures, but the subject need to name what kind of picture he's looking at. It is more like the condition of A2. Okay. And another one is a color picture, only the viewing. It is a B1. Another one is a color picture, and the subject need to do the naming task. Okay. So this is a B2. So actually, when you do this 2 by 2 factorial design, you will have 4 different conditions right there. Okay. With this kind of design, actually you can ask many different questions or discuss many different effects right here. The very first one is the main effects. If the main effects right here, for example, you'd like to discuss or investigate actually the difference between the task condition. For example, is there different brain activation would be focused, compare naming and the viewing condition? Then you can do in this one. Simply just combine A2 and B2 and do the subtraction or do the contrast between A2, B2 and A1, B1. So you can see the equation right here. We will say, I will summarize, I will give a summation of between A1 and B1, and I will do the contrast, compare this condition to actually combination of the A2 and B2 right here. So it's more like A1, B1 minus or subtracted by the A2, B2 right here. So the only effect right here, the only main effect right here is the task. The difference between A1, B1 and A2, B2 is the task condition. Okay. But if you'd like to investigate the main effect of the stimuli, whether the color picture will give any different of the brain activation, then now you are going to do the A1, A2, okay, use this as a group to compare with the B1, B2 right here. So we use the A1 plus A2 minus B1 plus B2. Okay, so this is the 2 group. So this is the way that we can actually consider different stimuli, different tasks right here, but we can investigate the main effect of the stimuli. Okay, so this is the 2 by 2 factorial design. And again, you can also consider the interaction. If you'd like to see the interaction between task and the stimuli, now actually you will do the contrast in this way. A1 minus B1 right here, A2 minus B2. As we may recall that when you do the contrast between A1 and B1, it is actually the difference induced by a stimuli under this specific task. In this case, it's a viewing. Okay, A1 and B1, the subject are doing the same thing, just viewing task, but the stimuli is given in different way. Okay, so when you do the contrast, it's more like the difference that induced by the stimuli. And again, this one is under the same task, but this time is under the naming task. But now you can see the difference induced by the color pictures. Okay, A2 and B2. And now you do the subtraction between these two categories. So now this is a more complicated one, but now you are allowed to investigate the interaction between task and stimuli. So now you can see the difference right here, but also the difference right here. So this is the interaction of task and stimuli. So in this case, we allow the interaction between factors. So we do not make the assumption of pure insertion. So this is the very different point that compared to the categorical design. Okay. The final one is the parametric design. In this case, actually, it's similar to the categorical design. It's not that complicated as the factorial design. We actually is considering one factor, that we actually just modulate one factor in this case. But in this case, we try to measuring our brain activity in a continuous way, not in a categorical way. We are not simply aimed to answer the question that is our brain have the different activation when seeing this one object compared to another one. This is categorical one, right? But now I'd like to see the extent, the level, the continuous changes of our brain activation. So in this case, we can actually take an example that maybe we can correlate the response times with brain activity. Please look at these pictures. Now we ask the subject to do the mental calculation. For the very first case, we say this is the lowest load, lowest mental load, because the subjects only need to do the so-called one-digit subtraction. 4 minus 1 equals to 3. When the numbers or the equation displayed on the screen, the subject is requested to determine whether the answer is correct or not. If this is the correct one, press the left button. If this is the wrong one, press the right button. Okay. But this is the lowest load right here. If you come to the, for example, this one, this is actually the middle level. Okay. You now ask your subject to do the two-digit subtraction right here. So now it is 36 minus 17 equals to 18. Is it the correct one? Definitely the wrong one. So now the subject need to press the right button. But you can imagine that compare these two different mental load. I mean the difficulty level right here. This one is definitely may take more time to allow the subject to do the decision whether this is the right one or wrong one. So we can anticipate that in this case, the response time may a little bit longer compared to this one, right? And when the equation comes to the three-digit numbers right here, 116 minus 22 right here equals to 96. Is it the right one or wrong one? Okay. So again, this mental load may be again higher than the previous one or this one. So the response time may be again longer compared to the other two. So now you will have, if you deliver, for example, 10 questions like this one, 10 questions like this one, and 10 questions like this one, and now you have 30 numbers. Each one represents the response time when the subject is determining whether the answer is right or not. Now you have 30 values right here. And now you'd like to actually correlate the value with the brain activity. Is there any linear relationship when the mental load increased? Is there increased brain activation or activity in your brain? So now when we say parametric design, this is the continuous measurement, continuous value behind. So you can actually do the correlation. For example, the Pearson correlation to actually unveil the relationship between brain activation and the behavior. Okay. So what kind of the equipment or the hardware and software we need to actually deliver the stimulus? Of course, the MRI is a very different place in the hospital. It actually has a very high magnetic field inside. So we definitely need the MRI compatible hardware. You cannot simply sending a usual monitor or TV into the scanning room. It would definitely sucked into the MRI because of the strong magnetic field. So you definitely need a so-called MRI compatible hardware. If you want to give the visual stimuli, for example, the equation right here, you need a projector or monitor. So there is so-called in-room. In some cases, because the projector is not the MRI compatible, people may actually put the projector outside the scanning room and project the imaging through the window that the operator can observe the condition of the patient or the subject. However, this kind of the imaging quality is pretty bad because it goes through a window. So actually, in-room hardware is better. You actually can bring the monitor or projector into the MRI scanner room, and then you can just do the image display or video display within the MRI room. Okay. And another one is the goggle. If you don't want to use the projector, you can use the goggle, just like some head-mounted display or something. You can just use a goggle. And using the goggle, you can also integrate it, a set of the eye tracking camera. So actually, you can determine whether the subject is looking at the target. Sometimes subject may not really looking at the target. It actually just goes to randomly position or something. So you can use an eye tracking camera to determine whether the eyeball is staying in the center position and looking at the subject or something. So the goggle with integrated eye tracking cameras is sometimes very useful for some kinds of the study design. And the third one is the audio system. Again, this kind of the earphone is not a regular one. It's actually, again, the MRI compatible one. And in some cases, you need response pads, grips, or buttons. This one is the grips. And sometimes you may give just like a game pad or something that the subject can press a button to give the best response. Like this is a right one or wrong one. Okay, this is the animated one or inanimated one. You need to allow the subject to do the response. So you will give him a pad with the buttons on it, and so he can press a button. Okay. And the final one, this is a particularly important one that we call trigger or synchronization box. Actually, this is the one that allow us can actually synchronize our visual or auditory or something, some kind of a stimuli with the same timing of the MR scanner. So once the scan is start, the deliver will start simultaneously. It's kind of a synchronization box to ensure the time synchronization is happened during the whole experiment. Okay. And besides the hardware, you definitely need the software. Software is the program that you can actually determine the procedure, which specific time point you'd like to display an animal picture on the screen. And how long after the first stimulus you'd like to give another picture. For example, 5 milliseconds after you'd like to display another maybe human face pictures. You need a software or you need a program. And there are actually 3 different common programs that you can use, but I only put two of them right here. The first one is ePrime. It's actually the biopack system right here. And another one, this one is the one that I used normally. Commonly, this one is a presentation. This is developed by the neurobehavioral system, the company of the neurobehavioral system. Okay, so there are actually 2 or 3 different options that you can learn, but these 2 are actually the commercial ones. So actually, it's cost I think around $50,000 NT per 3 years. I think it is not the one that you can buy one time and use forever. It's actually charged by year. Okay.
Is it group license or is it individual license?
Individual license, actually.
Ooh.
Individual, and sometimes it's actually the, this is the license that binding to specific device. You're not allowed to use one license for multiple PC or something. No, it's only binding to one PC or something. But it depends on the cost. If you pay more, actually it will give you like a USB dongle or something, USB key. You can just plug into any PC you'd like to use. But again, it's normally only allow you to use the license more like a 3 year, 1 year, 2 year, 3 year. I think it can be as long as the 5 year. But it will. When I say the 50,000 is more like a 3 year license. If you want to have a 5 year license, definitely cost more. Okay. And this another one is actually one of the management toolbox we call Saki toolbox. That one is actually the free one. It's a free toolbox. But I think most of people are using these two kinds of the presentation software. Okay. So when we say presentation, that means a stimulus presentation. Okay.